Hi, I'm Sweety Deena from Sastra Deemed to be University, supervised by Raghotaman Yamanamalli and co-supervised by Jogi Madhuprakash. I'm going to present my poster on mathematical modeling of cellulose and chitin degradation in the presence and absence of lytic polysaccharide monooxygenases, which can either be referred as LPM. The objective of this research is to construct a mathematical model to describe the degradation of cellulose and chitin in the presence and absence of LPM, and also examine the synergetic effects of the enzymes involved in cellulose degradation, that is endoglucanase, cellobiohydrolase, and beta-glucosidase, as well as the enzymes involved in chitin degradation, that is chitinase and beta-glucosaminidase, with and without the presence of LPM. The background of this research is to provide a framework to understand the dynamics of the enzyme and substrate interactions, including the impact of the LPM in the degradation using a mathematical model. So here in the degradation pathway, we can see that including LPMO in degradation pathway will provide the higher yield of the end product. That is, in case of chitin, it is N-acetyl D-glucosamine, and in case of cellulose, it is glucose. The end product will be more in the presence of LPMO compared in the absence of LPMO. So in this mathematical model, we predict the substrate concentration over time during the degradation, and the enzyme kinetics is also incorporated in the model. The methodology here involves initially to define the model parameters involved in the degradation. There is a kinetic parameters for each enzymes and the substrate, and the initial conditions is also defined, and the mathematical equations is developed using these parameters involved in the degradation, and also the inhibition is incorporated, and the degradation constants is also incorporated, with the parameter estimation being the next process, and sensitivity analysis, which gives which parameter or which enzymes influence the degradation the most. So this helps to identify that. And Python is used for numerically solving these mathematical equations, and later the model will be validated. The equation mentioned here denotes the rate of change of the radius over the time, where the parameters here involves surface area and the radius, and the summation term represents the contribution of different enzyme substrate complexes to the degradation process. So this model accounts for the processive nature of the enzyme, where multiple enzyme molecules can work on single chain of the substrate simultaneously. And the hydrolysis of these polysaccharide take place mainly due to the absorption, completion, and the breakdown reaction of the enzymes. And the rate of change of enzymes here denotes the decrease in the free enzyme is due to the absorption, and a negative sign is indicated there, where the positive sign indicates the increase in the free enzyme due to the desorption. So this is crucial for understanding the dynamics of the interactions between the enzyme and substrate, and also substrate particle. So the result here denotes without LPMO, the glucose yield is around 0.3, whereas with LPMO in the degradation pathway, it is more than 0.5. And the synergy between the different enzymes, that is endoglucanase, cellobiohydrolase, and beta-glucosidase, is lower compared when the enzymes are enhanced with LPMO. Here in chitin degradation, the N-acetyl D-glucosamine accumulation is slow when compared with the LPM, where around the time zone, where around the 10-hour time, the concentration is around 1 mole per liter, where in the presence of LPMO, around the 10th hour, it is 3 mole per liter. And the synergy between the enzymes, like different combinations, shows that chitinases and beta-glucosaminidase and LPMO shows the higher synergy and higher degradation activity. So this clearly mentions that having LPMO in the degradation pathway is useful for the efficient degradation of the polysaccharides. So still the model validation has to be done, and we acknowledge Sastra deemed to be university for the infrastructural support and research facilities, and this work was funded by Department of Biotechnology. Thank you.